This paper addresses a critical challenge in narrative AI, creating autonomous seeming characters within centralized story systems. Traditional planners like strips prioritize plot coherence but ignore human-like qualities, specifically intentionality, where actions are goal-driven, and belief, where worldviews are subjective. The authors bridge this gap with a novel model where characters form plans based on personal goals and their beliefs, even when they are inaccurate. The proposed model tracks one belief state per character, and this avoids the computational cost of possible worlds models. Two empirical studies validate this approach. First, a pirate domain analysis is performed, where participants rate plans with both intentionality and belief as significantly more believable than alternatives. Second, an interactive fishing game demonstrates that 88% of players accept the believability of NPCs anticipating their actions, while 77% demonstrate anticipation themselves. This work advances narrative planning by formalizing anticipation, where agents delegate actions to others, and proving its necessity for believable social interaction, including games, education, and therapy. Strong story systems or narrative planners face a unique tension. They must enforce author goals while making characters appear autonomous. Classical approaches like strips assume omniscient characters, which is impossible in real life. Prior belief models support uncertainty but track all possible worlds, which is computationally intractable. Meanwhile, intentional planners like Glaive handle goal-driven actions but lack belief representation. The author's proposed solution is a hybrid model using epistemic edges to encode belief states. Each character has one belief state and is updated only via observation. This allows for impossible plans if they are believed to be feasible. It also allows for anticipation, meaning delegating actions to others. Lastly, it leads to efficient computation, which is critical for real-life interactive narratives. Two key concepts help redefine valid plans. First, intentionality requires causal explanation. Actions must link to goals via causal chains. In the pirate domain example, Plan 1 involves stealing treasure from James, and it is intentional, since stealing directly achieves Marley's goal. Plan 4 involves stealing the map. It fails because map theft lacks causal justification. Second, belief consistency demands Plan begin from the character's subjective state. In Story 2, Marley ignores Blackbeard's actions, making Plan 5 expecting James to dig a valid plan, despite it is objectively impossible. These observations are extended to support anticipation. Specifically, Marley delegates digging to James because she believes 1. He can, because he's on the island, and 2. He will, because it achieves his goal. This modifies causal links to include belief propositions, enabling actions like inform or deceive. Thus, valid character plans require a path from a belief state to the goal, where every action is explained. Figure 1 in the paper classifies plans into 4 regions. The C circle, classical, contains objectively feasible plans, like Plan 3, where Marley steals from Blackbeard after he moves the treasure. The I circle contains intentional plans. These are goal-oriented plans with causal chains. For example, Plan 5's sequence remains intentional even if the treasure is gone. Finally, belief or B plans are subjectively plausible from a belief state. Plan 2 is such a plan, because Marley believes stealing the map helps, though it is unmotivated. The intersection I intersect B, like Plan 1 and 5, is the key. Those are plans both goal-driven and belief-consistent. In particular, Plan 5 fits this region because it's objectively impossible but internally coherent. In contrast, Plan 4 falls in the opposite, C minus I minus B. It is classically valid, but first, It is lacking intentionality because there is no goal link for stealing the map, and also it is lacking belief because Marley cannot know the location of Blackbeard. Now, anticipation occurs when the character's plan includes actions they expect others to perform. This is formalized as the character X believes action A by Y is explained if and only if X thinks A contributes to Y's goal and it is also possible. In the pirate domain, Plan 1 uses anticipation. I expect James will dig up the treasure, because Marley believes both James can dig because he's on the island, and James will dig because it achieves his goal. The introduction of anticipation expands valid plans beyond what previously intentional planners allowed. The pirate domain, as illustrated in Figure 2, shows how belief and intentionality interact. Plan 1 of Story 1 is in I intersect B intersect C. Marley anticipates James digging, this is through delegated action, then Marley steals. This plan is feasible, goal-driven, and belief-consistent. After Story 2, where treasure is taken, Plan 5 uses identical actions as Plan 1, but this lands in I intersect B minus C. The plan is still intentional because stealing achieves character goal, and is also belief-consistent because Marley believes treasure is buried, but it is now objectively impossible. Plan 5 is valid because Marley's intent and beliefs are internally coherent. Conversely, Plan 4 is in C minus I minus B, and it fails, because stealing the map lacks justification, as it doesn't advance Marley's goal, and also sailing to Port Royal contradicts Marley's ignorance of Blackbeard's location. This reveals believability hinges on internal consistency, not objective correctness. Study 1 in the paper systematically compared believability across plan types. First, all action sequences up to length 7 are generated for Marley to obtain treasure. Each sequence is split into story plan pairs by varying breakpoints. For example, the 3-step sail, dig, steal could produce a pair where story is step 1 and plan is step 2 plus step 3, or a pair where story is step 1 plus step 2 and plan is step 3. Now, plans are classified into I intersect B, I only, B only, and neither. Actions are translated into natural language where story is in present tense and plans are in the future tense starting with I expect. Participants see the initial state, a shared story context, and 2 sampled pairs. They choose which makes more sense for Marley, given her goals and beliefs. 60 valid responses are collected per pair of regions. The statistical results in Table 1 reveal 3 key insights. First, I intersect B plans are significantly preferred over all others. Second, belief consistency alone improves believability, but intentionality alone only shows marginal significance. Lastly, the last row tests whether plans with both features outperform those with just one. Both features mean I and B, and one meaning I or B. So the I-only plans are intentional but belief inconsistent, and the B-only plans are belief consistent but not intentional. The marginal p-value suggests participants weakly preferred I intersect B plans over these partial plans. These results indicate that while belief or intentionality alone offers some benefit, their combination is crucial for maximum believability. The second study tests the believability and naturalness of anticipation using an interactive fishing game. The player competes against an NPC named Crook to collect fish. Actions are taken in 2 locations, and actions are only observable when player and Crook are in the same location. In addition, competitors may secretly switch backs at the end. The Crook uses the author's proposed model, where its belief state tracks estimated fish in the player's bag and updates via observation. To prevent infinite belief nesting, the Crook is constrained to believe that the player would not switch. This study tests both NPC believability and player's anticipation. Two key findings emerged. First, for NPC believability, 72 out of 82 participants, or 88%, rated the crook's anticipatory actions as making sense. This validates the proposed model's ability to generate believable simulation of anticipation. Second, this is about player anticipation. 63 participants, or 77%, demonstrated anticipation. This included 28 who won the game, 11 who reported unobserved actions from the NPC, and 24 who reported unobserved action from the NPC when they were prompted. These results prove that humans accept NPC anticipation as believable. In summary, the presented planner aims to combine strengths while overcoming key limitations of prior models. Classical planners like strips ensure objective feasibility but ignore beliefs and anticipation. Intentional planners add causal goal alignment and conflict modeling, but assume full observability. As an example, they can't represent Marley's false belief in Plan 5. Among belief planners, Ostery uses dynamic epistemic logic for arbitrary theory of mind depth, but reasons over all possible worlds with high computational cost. Other models cap belief layer at 1. The author's proposed approach tracks belief state per character and formalizes anticipation by extending causal links to belief propositions, thereby enabling complex actions. 3 limitations guide future work. First, the current model lacks desire modeling. Agents can't prioritize goals, which can lead to strange behavior when there are conflicting goals. Second is reactive anticipation. Agents only plan during goal pursuit. After success, they stop modeling others. Proactive anticipation would continuously monitor risks using sustained intention frames. Third is the lack of uncertainty. In the current single belief state model, belief is singular and specific. In conclusion, this work establishes that believable character plans require a combination of intentionality and belief. The analysis of pirate domain plans proved plans that are both intentional and belief consistent are significantly more believable than alternatives, because they prioritize internal consistency over objective truth. The fishing game showed 88% of players accept NPC anticipation as realistic, while 77% use similar reasoning. The technical contributions of the paper include 1. Formalizing anticipation by delegated intentions. 2. Modeling belief efficiency with belief state semantics. And 3. Validation with large-scale studies. The key insight is that believability stems from characters appearing realistic. Applications include realistic NPCs in games, educational scenarios, and therapeutic storytelling.